Hi, I'm Cheryl, and this morning I'm going to do some movements in maths activities, ways in which you can use movement to either reinforce concepts or to reinforce key vocabulary. In last month's video, Andrea made reference to the fact of you pupils working for themselves, coming up with their own strategies before learning the method. And we're going to start with a way in which you could use movement to actually allow pupils to develop the concept themselves and to develop a key understanding. And to do this, I need a partner, for which Matt has agreed to be my guinea pig. So Matt, come on down. Okay, in this activity, we're going to use, well, I would normally use dance bands, so bands made of spandex. But to show that you, as any teacher could do themselves, this is an old pair of tights, just knotted to make a loop. And we're going to use these as a band that will enable us to get pupils initially to show us that they understand different shapes. So you can use the band to test understanding of shapes. So let's make a rectangle, a parallelogram. Can we do a rhombus? What's special about a rhombus? A rhombus is all four sides are the same, but the angles are not right angles, so we need to think how we can do that. And it might be we do it by kneeling and using our neck. We can do every kind of triangle, so we could do a right angle triangle, we can do an equilateral triangle, we can do an isosceles triangle, and we can do a scalene triangle. So we're able to do it. What other shapes are there? Well, square and rectangle are obviously relatively easy to do. What about a trapezium? Can we do a trapezium? Well, yeah, there's our trapezium, in that we have our two pairs of parallel sides. But is that the only way we could do a trapezium? Well, we could have a trapezium where we have a right angle at one end. So another trapezium. So we can use this in a whole variety of ways to test understanding simply of polygons. So I'm going to make a shape, and Matt is going to make exactly the same shape with his band. So first of all, we're going to make an isosceles triangle. We're going to make an isosceles triangle. Now at the moment, Matt and I have different size bands, different size triangles. Doesn't matter, they are both isosceles triangles. But if we decide to then move on and ask the pupils to think about translations, then the key facts on a translation we need pupils to remember are that the size is unchanged, the orientation is unchanged, and the only thing that changes is the position on the page, on the board, on the plane. And so what we're going to do is I'm going to make a shape, and Matt is going to do a translation of the shape. So I'm going to make a right angle triangle. Now, are our triangles the same? How can we tell? Well, one thing we could do is move round.
Uh-oh.
Uh-oh, Matt's isn't the same. So once we've got them the same, we can then turn round again, and we've got the translation. It could be I take a step forward. Actually, my translation was the same. If I step back or to the side, we're moving the same shape around the plane, so the shape is being translated. So as the pupils are doing this, you can actually walk around the room, you can assess understanding, you can use it to test key vocabulary. You might, as the teacher, decide to start by getting everyone to have their own bands, to work on their own, and just reinforce understanding of shapes. Can they make a square? Can they make a rectangle? Can they make a right angle triangle? So you can use it to assess understanding of just the shapes. You can then move on to doing the translations. You'll have noticed that when we did the translations, when we checked to see if Matt's shape was the same size as mine, when we turned round, we ended up with a reflection. And so we can use the bands and other activities as a way of teaching reflection as a practical activity. if you were doing it initially with a class, you might well decide to buy from Walmart some of the very large mirrors that are $2 or $3 and have 2 or 3 of them in the classroom and have pupils walking backwards and forwards and thinking about, does my reflection get nearer, does it get further away, can I shake hands with my reflection, and ask a variety of questions like that. Having done that, we can then go on to a whole class activity which requires pupils to think about what reflections are. Initially we're not going to use the bands, but what Matt and I are going to do is we're going to use our drawing fingers and we're going to draw a mirror. So we're going to draw a mirror, across, round and up. So we've drawn our mirror. Matt is going to be my reflection. You can see that as you're doing that, it becomes almost a form of dance. And pupils, when they first start doing this, can perhaps make the movements jerky. And if they make it jerky, it's really difficult for the person who's being the reflection to follow. So one of the things as a teacher you need to do is to impress on the pupils slow, smooth movements so that it really does become a reflection. And actually it can link really strongly with dance, with physical education. So having done a variety of reflections where you're facing each other, when we do reflections in maths classrooms, we don't look into a mirror. We draw a line on the page, we draw a shape, and the pupils are asked to reflect it, which is very different to me looking in the mirror myself. And so what you can then move on to do is to, with the pupils, actually get them to physically do this. So Matt and I are going to draw a mirror, and this time I'm going to draw a really big mirror. So we're going to draw a really big mirror this time. Okay, and now we're going to turn round and we're going to be side by side. And this time Matt is going to reflect my movements. Now, if we stop, has Matt reflected my movement? Because if we were in the mirror, what would be, remember our image is the same distance from the mirror line as the object, so actually for Matt it's not that arm, it's the other arm. And so we bring our reflections round and down. You can use height, you can use arms, you can use legs, and so on. So that you can actually, as the pupils are doing that, and pupils find that much harder, what you're able to do is you can walk around, you can use, as we did there with Matt, where Matt put the same arm out as me, where actually you want the other arm out for the reflection. You, the teacher, are able to circulate around the classroom and are able to get some really good instant formative assessment on, can your pupils understand the concept? Okay, you can also go on to using the bands for reflections. So we still have our mirror here, and these then become much more like the questions that pupils might be faced with in a textbook, where we often see a mirror line, we have a triangle drawn on one side of the mirror line, and the pupils are asked to reflect to the other. We're going to use exactly this, but with movement. So I have done a right angled triangle, so Matt has to be my reflection. Now has he, so again, okay, so it's the notion of remembering it is, and we can check by moving round, come back again to our position, and we can carry on doing that in different ways. With a class, you would get the pupils to alternate between the reflection and the person doing the movements initially, so that everybody has a chance to be the follower and everyone has the chance to be the person who's making the reflection. Right, we'll stop at that point of these and put the bands down, and we're going to move on then to some other activities that you can use, physical movements you can do to reinforce key formulae or key mathematical language. Okay, this final bit is going to be looking at ways in which we can use movement to reinforce either formulae or to make sure pupils understand key mathematical vocabulary. When we do rectangles, pupils are pretty good at remembering that the area of a rectangle is the base times the height. But when we go on to doing areas of triangles, a really common error is that pupils forget to divide by 2. They forget to do the halving because they're just formulae that they've learned. But you can give some movements as a way to help pupils remember. And one way to do it is when we do the area of a rectangle, we say area of a rectangle is base times height. Area of a rectangle is base times height. Which then means that when we go on to doing the area of a triangle, we can say area of a triangle is base times height divided in 2. So area of a triangle is base times height divided in 2. And what you notice is that pupils are actually dividing the rectangle into 2 triangles. So it's clearly linking back to that notion which you will have hopefully done by practice, by drawing, by counting, in all sorts of other ways. Actually, you're reinforcing that formula with a way that many pupils can actually, and I've actually seen pupils when they've been in the test going like that in a test as they were trying to remember what the formula was. Another bit of vocabulary that pupils sometimes get confused on is parallel and perpendicular. Which is a parallel line? Which is a perpendicular line? And many teachers, when they teach parallel lines, first introduce the notion that parallel lines are like railway tracks. They go on forever and ever. And you can use that as a way to help pupils just reinforce it by actually just have them standing up and going parallel, perpendicular, parallel, perpendicular, parallel, perpendicular, parallel, perpendicular, parallel, perpendicular, and so on. And it actually ends up sounding like that train, which really can make it stick in the mind. If you are wanting to check understanding of different kinds of angles, are pupils sure what an acute angle looks like, what a right angle looks like, what an obtuse angle looks like, or what a straight angle looks like? You can do that by arm movement. So, acute angle, right angle, obtuse angle, straight angle, acute, obtuse, right, straight, obtuse, acute. And you can actually have pupils doing that. And again, it's very quick for you to be able to quickly assess what can we do it. In addition to the fact, these kinds of things are really nice little bits of brain gym. So when the pupils have been sitting there for a while, you want to get them refocused before you move on to something else. Actually getting them standing up, doing a quick bit of revision of that can really make a difference. And the final thing we're going to do is how we could use a song-linked movement. Now here's where my disclaimer is, I can't sing to save my life. Okay, so that's my disclaimer.
We're in it together.
But pupils, it can help them. And often pupils get confused. Which is the formula for the area of a circle? Which is the formula for the circumference of a circle? And so you can actually help them to remember that using a song. So, I think you all know the song Kumbaya. So here we go. 2 pi r circumference, 2 pi r. 2 pi r circumference, 2 pi r. 2 pi r circumference, 2 pi r. Oh, circumference, 2 pi r. If you're interested in using songs in maths lessons, there are a huge number of maths songs out there. If you Google maths songs, lots come up. Many of them are created by teachers and pupils, and you see the class making a rap or a song. Others are to traditional songs. There is a really good one that is about pie to the tune American Pie by Don McLean. So there's a lot of things like that, and it might be that you find an odd one that you want to use with your pupils. Okay, so in conclusion, hopefully you've seen that actually maths doesn't have to be a sitting at your desk activity. Maths can be having the pupils out of their seats, it can be singing, it can be dancing, it can be movement. Actually, if we're doing those kinds of things, what that's doing is meeting the needs of different kinds of learning styles. We're meeting the needs of the kinesthetic learners, we're meeting the needs of the auditory learners, and we're meeting the needs of the visual learners. And actually, every pupil needs to have a diet of all of those. And the more of that you can do, the more your pupils are going to see maths is more than just work from a textbook.